compare real numbers. Vocabulary. An irrational number cannot be expressed as a ratio of two integers. We've already talked about what a rational number is, so the opposite is an irrational number. Remember that it is non-terminating and non-repeating. It's very important that it fits both of these criteria. Here are some examples of rational numbers, just to refresh. -2, 5, 3.76, where the 7 and 6 are both repeating, -12 and 7/8. So it could be a decimal, a fraction, positive, negative, whole, an integer, natural. We've talked about the several different kinds of rational numbers. Irrational numbers, remember, are the opposite of these. So square root of 2, square root of 17, pi, you should be familiar with, and this decimal, 1.2123, 1234, and you see the ellipse. This means it continues on and on. Notice that non-terminating means it doesn't stop, and non-repeating. There is no single digit repeated. Real numbers. All of the rational and irrational numbers. So this is the largest group of numbers. We call them real. It has all the rational and irrational inside. Big number 1. The square root of any number that is not a perfect square is called irrational. So square root of 25. 25 you know is a perfect square. And if you take the square root of 25, you get 5. Well, 5 is rational. So the square root of 25 is also rational. The square root of 28. 28 is not a perfect square. All right, so that means when you try to take the square root of it, you get an irrational number. Name all the sets of numbers that each real number belongs to. So example 1, 0.25, where the 2 and 5 are both repeated. 25, 25, 25, and it keeps on going. All 4 examples are real numbers. Now, because it is a repeating decimal, we know that it's rational. It's not a whole number, it's not an integer, it's not a natural number. Example 2, the square root of 36. Well, 36 is a perfect square, so when I take the square root of it, I get 6. Well, 6 is again a real number. 6 is also rational. It could be 6 over 1. That's the ratio of two integers. 6 is an integer. It's a positive or negative whole number. So again, a whole number, and it's natural. It's a regular counting number. Example number 3, the negative square root of 7. 7 is not a perfect square, so when I take the square root of it, I get something irrational. It will be a non-repeating and non-terminating decimal. Example number 4, 0. Remember that 0 is a whole number, but it is not a natural number. It's also part of the integers, and it's also rational. I could write 0 divided by 1, and I still get 0. Use less than, greater than, or equal to make the statement true. Example number 5, the square root of 7, and comparing it to 2 and 2/3. So you want to use your calculator and type in the square root of 7 and get a decimal approximation. So I see that it's about 2.646. All right, and I rounded. And 2 and 2/3. Well, 2/3 is 0.6 repeating, so 2 and 2/3 would be 2.6 with the 6 repeating. Well, if the 6 is repeating, that means there's a bunch of 6's. So they're the same where the 2's are, they're the same where the first 6 is, but then I compare the 4 to the 6, and this 6 is bigger than that 4. So I'll say that 2 and 2/3 is greater than the square root of 7. Example number 6. 15.7% compared to the square root of 2/100. In order to change a percentage to a decimal, you simply move the decimal 2 places to the left. So as a decimal, this would be 0.0157. The square root of 2/100 you can type into your calculator, and you get 0.141, and I round it. Let's compare these. Well, the 0 out front is the same in both. Then we have our decimal, then we have 1 in the tenths place, and then here's where they're different, 5 and 4. Well, 5 is clearly bigger than 4, so I'll put greater than in this bubble. Example number 7. Order the set. The square root of 30, 6, 5 and 4/5, 5.3 with the 6 repeating. From least to greatest. And plot them on a number line. You want to change all 4 of these numbers into decimal form so that they're easy to compare. If they're all in the same form, you can see which one's the biggest and which one's the smallest. The square root of 30, you can type that in your calculator. And these are approximate symbols, so 5.48. 5 and 4/5. Well, you can type in 4 divided by 5 in your calculator and you get 0.8, so 5.8. And remember, you can always add zeros to the end of any number. 6 is 6.00. 5.36 with just the 6 repeating. Well, if there's another 6, then that would round, this 6 would round this up to a 7, so 5.37. And now I can put them in order from least to greatest, and I've listed them here on my number line. 5.36 with the 6 repeating, square root of 30, 5 and 4/5, and then 6. Make sure you pay attention to these questions and the order that they ask you to put it in, whether it's least to greatest or greatest to least.